Hi guys, from Shed Hacks again. Okay, this is to help those doing construction technology exams, and this is Unit 1, Thursday the 9th of January. Sorry, I made a mistake on the last one. I said it was February when it was January, and this was a year ago roughly. Okay, so let's go through it. Same rules apply. Black ink, ballpoint pen, and just make sure you read the questions, answer all the questions, and you fill in the spaces provided. Okay, paper 60 marks. Okay, right, and it covers actually for the level 1 and level 2 first award and extended certificate courses. Okay, I'm just going to masking tape this down there so you can see it clearly. There, nice and clearly. Right, I hope this goes well for you, and I hope you get full marks when you do exam this year. Good luck to you all. Okay, so a low-rise building, low-rise buildings have performance requirements. Okay, draw a line to match each material stroke component to its associated performance requirement. Bit of a wordy sentence, really, to match words together, but there you go. Each material stroke component has only one performance requirement. Okay. So they're saying match these up and it only has one each. Well, flashings is the lead or the zinc, very thin metal zinc and lead around the house windows and chimneys, and where there's a junction at a tile, perhaps at a certain angle where they can't actually join it very carefully. And you see this around many houses. And I think this is only to do with weather resistance. It's not to do with stability. It's not to do with security. Nothing to do with insulation or strength, really. Right, so that one would therefore be this. Okay. Plasterboard layers. Interesting, this one, because actually it's not weather resistance. It's not really stability. Although it does make the internal walls a little bit more stable, certainly if it's partition walls. Security, no, not really designed for security, although it does divide walls, of course, internal walls. It's more to do with sound insulation, but it does provide strength, but I'm going to go for sound insulation. I think that's the main function of the plasterboard layers. It's going to have more than one layer. I think that's what it's suggesting, layers. Okay, this question here, so this is part B of number 1. Identify 2 types of load that a building is designed to resist. Okay, so 2 types of load that a building is designed to take, really, that's it. Okay, well, aesthetic is about the looks of the building, so it's not about that. Wind, yes, you get wind loads, they impose loads on the building. Economic, no, that's about money, so it's not that one. Nothing to do with money. Sustainable, no, it's not to do with how long the building lasts, really, and how it's made, not really. Self-weight, yes, the clues, the weight part, okay, and load, as you know, is all to do with forces. So we're going to go for self-weight and the wind imposed load. And the self-weight, as you know, is a dead load. Dead load. And wind is imposed. It's an imposed load. So snow and rain and so forth. Okay, moving on to part C here. Name 2 materials from a traditionally built house that could be recycled when the building is demolished. Traditionally built, presuming this is brick and block and tile roof. Okay, and demolish is to take down, isn't it? To break up. Okay, so we're going to go for, I think brickwork would be logical. Sorry about my handwriting, but I'm doing it rather quickly today. And they could be engineering bricks, or they could be facing bricks. Some research for you to do. I would research some of these words in your spare time to make sure you really know what you're doing here. Okay, I do urge you to do that. A bit of research on your phone, perhaps. And the other one, of course, as I mentioned, is tiles. Now, tiles are very expensive. they're not very sustainable in the way they're made most of the times. They can be made from clay. They can be made from natural slate from the Welsh mountains and around the world, and they can be formed in concrete. Okay, there's other ones. You can get composite tiles now made from types of plastics. Okay, so they can be recycled. Okay, and part B here, A, B, C, D rather. Identify 2 types of sound insulation. Okay, something to stop sound travelling through it. Use within a building. Okay, sound insulation, 2 types I want. Okay, so triple glazing possibly. Timbering, no, that's to do with foundation support. I think that's what they're saying. Guttering, no, I don't think that makes any difference to sound at all. Carpeting definitely does. It deadens the sound. And mood boards, well, no, then that's a graphical term. That means to show a range of ideas. Okay, so we're going to go for carpeting. It deadens the sound inside a building, and triple glazing definitely keeps out sound. Okay. E, identify 2 locations in a building where sound insulation material can be placed to reduce the passage of sound. Well, it can only go in various places, such as the floors. Can only go in the floors if they're hollow. So floor space. So yeah, that's an interesting one. Lighting, no, it's nothing to do with lighting. You wouldn't put it in excavations. That's when you dig a hole, so that wouldn't make any sense. And walls, definitely walls. Interesting, because if it's a solid floor, you couldn't put it in that very easily, although they do use types of insulation, which is the plastic foam-based insulation in floors. Okay, plenty of companies do that sort of thing. Expanded polyurethane foam it is, actually. Okay, and question 2, temporary roads. These are roads that aren't going to be used forever, temporary. And hard standing areas are features shown on a site layout plan. Okay, so this is a construction site. Okay, and the layout is looking down from the top. And you're looking at other aspects. Name 2 other features or aspects shown on a site layout plan. So it's the way things are laid out on site. Okay, so I would say common sense points I would be welfare, facilities. I've written some of these answers out first just to speed things up. And first aid unit and a canteen unit. And first aid can include toilets, which is a must, of course. I think that's a legal requirement now for all these on a large site. Even some small sites as well. Storage could be one. You want to know where storage should be, and opposed to storage, you want to know where waste segregation should be. Okay, waste areas, and I suppose you might know them as basically skips. Okay, skips for wood, skips for glass, skips for plastic, skips for metals. Okay, very important that we segregate. That means separate the waste so it can be taken away and recycled. Okay, moving on to question 3. Name 1 type of internal partition wall. Okay, well, partition walls are generally internal anyway, but name 1 type. Well, the one that's most commonly known is made from plasterboard and stud timber. So it's called a stud partition. Okay, usually I'm going to put, this is to help you, a combination of timber and plaster board. Okay, timber and plaster board. Okay, now this diagram here on question 4 shows a section through a foundation, and the foundation is here, and it shows these section through it. Okay, so the section is actually looking across it there. Okay, right. Okay, so let's go for this. We can see the DPC, the damp proof course, and we can see the concrete cavity fill here. Concrete cavity fill. This is below the ground level. There's the ground. This is the foundation and mass concrete, and it's a strip foundation type. They could call it just mass concrete. And yes, that is a strip foundation, a shallow strip. I'll label that strip. And that's the symbol for brickwork. The clue is on the outside. I hope you're enjoying this, guys. Getting through it. So get to know these diagrams. This comes up time and time again. That there, I know they haven't labelled it, is actually the cavity insulation. So insulation. And the gap between the brick and blockwork is the cavity. Same as a hole in your tooth. The hole in the wall there. Between the two layers. And this is the earth here. That's a symbol for earth. Brilliant. Okay. Now this is a tricky question here, and I've done a little bit here. I'll go over and I'll go through it as we go through it. It's worth 5 marks, so it's important we know these. Sketch a cross section through a raft foundation. So get to know your foundation types. This is a raft foundation, and there are many books that cover this for this course, but get to know them and label them. So raft foundation, and it's supporting a cavity wall. Well, there's your cavity wall, so that's easy peasy. So you can copy that part, and you just got to know the type of design for the raft. So let's just copy this. I'm going to do this, I should do this on a ruler, so let's get one out of my drawer so we can get this right. Here. Right, so here's my ruler. There's the cavity I've just drawn. I'm drawing it nice and large for you. And here is the raft. Now, when you're studying for this, you're revising, I urge you, you must know your foundation types. If you don't, it's going to really cause you a few problems. I'm just going to rub out that little bit there, that mark I've made. And I'm going to go over my marks and I'll show you. So we're drawing now the insulation. There's the insulation. And we're drawing the various floor layers. Now you've got a floor screed of thinner concrete. Normally self-leveling, normally about 50 mil, and you have another floor screed here, so you can have 2 in effect. So a self-leveling one and another one. That's normally about 100 mil, and this is normally about 200 mil. Okay, that's the distance. So I'm going to put floor screeds. Okay, insulation. There's your. I'll put that there. Insulation. That's that expanded polystyrene foam. Different types you can get these days. On the inside, you show on the outside wall, you show your DPC. Dot and dash. Dot and dash. Make it clear. And actually, down the wall here, running underneath this insulation in here, should be what they call DPN. Now, the clue is DP, so there's damp proof, and it's not on a course of bricks as these are, not in between a course of bricks. It's actually a membrane, so it's a damp proof membrane. Okay, and here they're in between a course of bricks or blocks. It's a damp proof course. Now above the cavity fill there should be some insulation. I can draw this. And then you have your concrete cavity fill, and this is just concrete or dense mortar can be used. And it slopes in, so if there's any water that does drip down that cavity, it drips towards the outside wall. That's the idea. So it should be just skimmed off towards the wall. Now the symbol for the block work here is a line that way and a line that way. In the exam you might have time to do this with a ruler. And for brickwork it's a double line. Like that. Okay, I'm going to show the ground here, perhaps with a little flower here, why not? And that's a symbol for earth. And of course there's earth all around the raft foundation, which is what we're drawing, of course. Now let's just draw the bottom of the raft. Often at the bottom here there will be hardcore old bricks and blocks put there, and there's usually some blinding sand, so that's just sand blinding, about 100 mil thick maybe. Well, let's go for blinding. It's just sand blinding. I put sand. Just levels out the hardcore, and you put some hardcore down here, and they're just literally it's just rocks and broken bricks, and it allows that sand to become level, and you can build upon it. And it means the hardcore and the blinding doesn't then contaminate the concrete when you pour it. And it should continue down here. Actually, you can put hardcore and blinding here as well, and that stops, as I say, the contamination of the concrete when you pour it. Contamination is damage, isn't it? Now, even the actual raft here, massive chunk of concrete under the wall, varies in depth depending on the weight and the design of the house. You may have some reinforcement bars that go straight on, okay, and you may have a couple of those that go right the way through the slab or the raft, right along. Traditional ones, I'm showing an arrow. And then it's quite often in the deeper part they actually have a reinforcement cage, so it's like a cage of reinforcement bar forming almost a ground beam. Look up ground beam, something like that, and this is a reinforced box, if you like, in the concrete, embedded. And the cover between the outside of the concrete to the reinforcement should be about 50 millimeters. Anything less than that, and then the water can start corroding the actual steel. So we can call this reinforcement bars. Okay, all this. There's an end, so it goes that way, and there's a side. So we make a sort of a cage, and these interconnect, and it goes through the slab that way as well. And it takes the tension and compression forces. Well, it's actually tensional forces. That's the idea of the reinforcement. The compression is taken by the actual concrete. So that's what it's good for. And I'm going to show it's cut off there with a little symbol there, little dash. And there it all is. That's your raft foundation. Okay, and the little symbol for concrete here is little dots and dashes. I think I've done everything. Dots and dashes for the screed. Floor. All mass concrete. Okay, there you go. Looks neat. That's binding is another name for sand. Oh, I like doing that. There's your insulation. Okay, brilliant. So you could label it, that's the cavity fill, DPC brickwork, and you get your marks for all your labelling, DPC insulation. Now we're running out of time here, so we're going to have to crack on here. So just label that cavity fill there. Cavity fill, and that's that. Okay, brilliant. Okay, hope you like that. Right, okay, it's my ruler rattling. Number 6, explain one advantage and one disadvantage of a strip foundation. Right, a strip foundation, they are used in many buildings, normally domestic buildings. And let's have a look at a little diagram, if I can, of strip foundation. If I can find one in my book here. The foundations, these are cost effective. And let's have a quick look at this book here. There are the foundation types. They're the types here. So strip, deep strip, raft and pile. Get to know these from your notes, guys. And there's some really good books on this actually. That's the one we've just drawn. But yeah, look at that. You can stop the video there if you want to and get to know those. And it even points out the advantages and disadvantages of each. Okay, so there you go. Even shows a beam and block floor here. And that's a good book, that one. Okay, so let's go back to this. They're fast to construct. So that's an advantage. I know I've done 2, but I'm giving you more ideas. Disadvantage, does not provide a floor because you've got that hollow, yeah? Well, the raft foundation provides a floor, look. But the strip foundation stone, you have to build a floor off it. Okay, there's an example. You have to come off and build the beam and block floor in that case. So, okay. Ground has to be relatively stable. Okay, you've got to have fairly good ground quality to use a strip foundation. Can involve brick work below, and that's important, below ground level. Yes, now if you're doing a deep strip foundation, look, you've got brickwork below the ground level, and that can be a dangerous operation if it's quite low. Okay, one worth noting. Right, and let's have a look at this question, number 7. Give one function of a wall opening, a function, the reason, reason I suppose, function, to allow a window or door to be positioned. Common sense, that is. Yeah, but you need to know what a wall opening is. Basically, it's a hole in the wall, isn't it? Okay. Name one component of a wall opening. Well, there's loads of components of a wall opening, actually. You've got the lintel above the opening to hold up the brickwork or blockwork. Okay, it's the beam basically above. It's a posh name for a beam. You've got a vertical moisture area, DPM type thing. You've got a cavity tray. I would research these. You have a window, you have a sill at the bottom, you have a threshold at the bottom of a door, sill at the bottom of a window. You have a cavity closer on the sides, stops some moisture getting into around the windows, and also provides in some cases fixing for the window and door. fixing them in somewhere to secure the actual door and window to it. Okay, so more there than you need, but look up these, research these on your computer. Okay, bit of a funny question this, number 8. Straw bales, literally made out of straw, are used in sustainable construction. So sustainable means it's not damaging in any way the planet when it's been used. Name the building element that straw bales are used to construct. Usually it's the internal wall. Internal insulation. Where in dry areas okay. Where in dry areas only, because straw takes moisture. It's hygroscopic, so it draws in moisture and therefore can only be used where there's dry areas. Possible internal wall, I've got. Possible internal walls. Yeah, that's what it can be used for. Clever. It's highly compacted and normally combined with some sort of safe resin to bond it together. Explain 2 reasons why the use of straw bales is a sustainable form of construction. Well, straw is natural. Straw is naturally occurring. Okay? Naturally occurring and plant based. That's why. Okay? So that's one point. Another point, can be allowed to be taken to landfill. Yeah, can be allowed to be taken to landfill without causing damage. Without causing damage to the earth. And that is the whole thing about sustainability. Okay, not damaging the earth. Full stop. Don't forget your punctuation, guys. It's important. Okay, should be doing quite well here. Okay, now a bit of maths here. It's only basic maths, so you should be fine. Everyone should be fine on this. Okay, so they're looking at an excavation, and they're looking at finding the volume of it. A trench. So something's been dug to form probably, as I say, a foundation. We've looked at these, so you're digging down into the ground. And often you have to make a hole, obviously, in that case. And you're excavating, that's digging. And you're digging for a drainage pipe, fine. Okay, so you're digging a hole for a drainage pipe. So here, it's a big hole there, and they want to put a drainage pipe at the bottom. Okay. There's our earth. Okay. And that hole they're saying is 40 metres long, going that way. They're saying it's 0.6 wide and 2.4 deep that way. Okay. And that way it's 0.6. So it's just over half a metre wide. 2.4 metres is high. It's about 2. It's a very, very tall man, that would be, and so about 6'7", so above your head. So it's quite a big excavation. Calculate the volume, easy peasy, lemon squeezy. So volume is height times length times depth. Any combination of that can be, change it round, and it's in meters cubed because there's 3 dimensions. And it can be done in any order. In any order, multiply these. So 40 times 0.6 times 2.4. Okay, and I'll calculate that in my head, and that is 57. Yeah, 57.6, and that's been just cubed. And actually, although that is the volume coming out of the ground, often you add on 10% can be added for bulking. Sometimes it's 20%, but 10%. So actually you can add on 10% in the real world to make that actually what it would be. Because of course when you excavate, as you know, digging in the ground, you tend to have a lot of air that you generate, and therefore the actual volume increases. You probably notice that when you're digging sand up or mud in the garden. Fill a bucket and think, blimey, where's all that come from? Okay, so question 10. Explain 2 benefits of using eco joists instead of a solid timber joist for construction of an upper floor to a low-rise building. Low-rise is up to 3-storey normally. Okay, so I'm going to draw one for you, which I've quickly drawn here. There's a top beam section of timber there. And there's your top section of timber. This could be 10 metres long. This could be. And then let's do another one. Okay. And then in between, if you had a joist 10 metres long and it was solid, it would be enormously thick to take any load. So I say thick, deep it would be. So say it's, you know, 400 millimetres deep, which often they are. You'd have a massive chunk of timber. So what they do, they have a piece of timber at the top and the bottom, decent timber, strong structural timber, and then they actually have small pieces in between. And remember, when you're building a beam, it's the depth of section that makes it stronger. It's not necessarily the width, it's how deep it is. You'll notice that if you muck around with a bit of paper, try and put load on it, it's the depth that really counts. And you've just got to keep it from buckling. And often they may have even some metal straps to stop it buckling.